Hello, everyone. Welcome to Addressing Intelligibility in Your Audio Systems and Environment. It's presented by Dan Shore and Ian Weingold. This webinar is brought to you by today's sponsor, TOA. Before I hand the presentation over to today's presenters, there are a couple of housekeeping items I must address first. For the CTS holders among you viewing our presentation live, today's webinar qualifies for one renewal unit for the CTS and the CTSD, but none for the CTSI. Please allow up to 5 business days for those to appear on your transcripts. If you have any issues, please contact AVIXA's webinar team directly at webinars@avixa.org. Today's webinar should last between 45 and 60 minutes, and all attendees have been placed on mute. If you have any questions during our presentation, please enter them into the Q&A window so today's moderators can address them at the end of the presentation. To access this Q&A window, move your cursor towards the live stream video box, locate the Q&A icon, and type away. Just please be mindful that there is a separate menu for the chat and to not put your questions there, as they will not be recorded. You will have access to this webinar within about 5 business days, up to 7, and that's all from AVIXA for now, and on to our presentation. Take it away, gentlemen.
Good morning,
Very
Dan.
good, thank you. Good morning.
Afternoon, wherever you are in the USA.
All righty.
Everybody's saying hello down in the bottom there, Dan. So you are in
Yes,
Chicago.
I am in Chicago. You are in Florida and
I'm in
enjoying the
Central
weather.
Florida. So I see people logging in from all over the place saying hello and announcing where they're at. So we didn't want to miss that opportunity.
Well, very good. I think we'll get started on this. Looks like we have a good crowd of folks here. So I am Dan Shore. I'm the engineering manager for TOA Electronics, and Ian is our national education sales manager. We're both very involved with how things sound using our equipment. And so we are decided to put on this presentation. We are obviously not acousticians. I highly recommend that you get to know your local acoustician because they can be extremely helpful to you in getting some of these issues taken care of. So what we're going to do today is go over some common scenarios and some common fixes for these. And then we're going to take your questions. Hopefully there'll be something of interest for everyone in this presentation. All right, so let's get started. We're going to do an intro, definitions, causes of poor intelligibility, some possible remedies depending on the situation, and some final tips and takeaways. All right, so let's start by going way, way back.
In the beginning.
In the beginning, yes. Going back to Greek theater, which depending on the part of Greece you were in or the particular gods that you were trying to bribe to get some stuff for you. This theater, the theater of Epidaurus, is one of the most famous theaters in the world. It has some of the best acoustics in the world. It had a large number of people in it. Obviously, great signal to noise ratio because it's in a quiet countryside, very low late reflections. Again, it's an outside venue. And the geometry of the bowl makes it very, very efficient for early reflections to amplify sound. It is one of the greats. They still do concerts there. And it's one of the world's greatest achievements out there. So this was primarily for spoken word. And as we progressed to instrumental music much, much later, we look at something like the Cathedral of Notre Dame, which is the exact opposite. All right, extremely long reverb times in here. I didn't include the actual reverb times in here, but I'm imagining that they're 7, 8 seconds long. And the idea there is to amplify and enrich the musical portion of the content for example, organs or Byzantine chants, Gregorian chants,
Gregorian chants. Fantastic.
exactly, everything. All right, so two different, completely different uses for acoustics in here. And as we get into this, there we'll go over a couple of optimal acoustic measurements and times that will be represent modern thought on this. All right, so who needs intelligibility for their systems? Well, obviously, life safety systems need that. We deal with that every day um, with people requesting certain standards be met for speech transmission index values and using STIPA measurements to shorten those up. And this is part of NFPA 72, and they're looking for a specific value on this. The quality of the sound is not as important as the intelligibility of the sound. Public
Make sure
address
everybody
system,
understands, Dan, NFPA would be a fire rating standard, correct?
the
For,
National
for,
Fire
for fire
Protection.
alarm.
So yes, NFPA 72 is for uh, emergency communication systems, and so the other systems that are important under this would be just a straight public address system. The whole point of a public address system is to output intelligible information to the public. Background music is one thing. Intelligible announcements are another, in case you've lost a child, right? Music is important in house of worship, but in most religions, the spoken word is most important, and intelligibility. We run into all kinds of churches where no attention has been paid to acoustics or treatment or anything like that. All right, so let's get some definitions here, and you'll hear these throughout. The frequencies that we're going to be dealing with primarily in this webinar are frequencies from 400 hertz to 4,000 hertz. Now, the human voice can obviously produce frequencies lower than that, but these will give you the ability to determine the difference between a B and a V or a T and a P. So they're very, very important. Sound pressure level is what we typically see listed in dB, but the actual measurement is a pressure gradient, and that's measured in pascals. That's beyond the scope of today's presentation. Speech transmission index. This is very important for measurement and documentation of your system if you have to meet a certain standard or if you want to be sure that the system that you designed is going to be intelligible. All right, and you can model this, you can test for it, but the model is a model of a test, which is also a model. The only actual standard is 30 people wandering around and saying that they can all clearly hear what's going on. So speech transmission index is a long series of tests that you have to do. The rating is from 0 to 1, with 0 being completely unintelligible and 1 being completely intelligible. And 0.5 is generally acceptable. 0.6 is a good intelligibility score. STIPA is a derivative of STI. STIPA is a testing sequence for public address systems, and it allows you to get quick measurements, relatively quick measurements. You're still going to do an average of your tests, but it's not going to require the number of tests, the number of spots that you do, and it is fairly well accepted by any authority having jurisdiction, and that's generally how you'll test it. There are STIPA test kits out there. They use a very special tone. It's not pink noise. It's a modulated signal that sounds somewhat like a spacecraft going by. It's very, very easy to do these days. It used to be much, much harder, but getting this step of reading, if you're concerned about intelligibility, is very important to have in your kit and to be able to document. You may want to have an acoustical consultant do this or an acoustician do this if you don't have the tools. It may be cheaper to rent them and their tools than for you to buy the tools. Primarily, what they're going to be concerned with is the RT60 of the system or the room, sorry. And that is the length of time it takes for a signal to decay from its current value down 60 dB. So a typical concert hall RT60 is about 1.85 seconds for orchestral music. It's a little bit longer than you would use for, say, a lecture hall or a classroom. Um, again, if you're going for a cathedral effect, then that's going to be obviously up in the 3 to 5 second range or longer, depending on your source material. Early reflections are important. Early reflections increase the sound level, don't affect the intelligibility. Late reflections can start to degrade the intelligibility of the sound, and late reflections are those that arrive after about 100 milliseconds. The most destructive of these is echo, which is a distinct repetition of sounds, and we can help get rid of or greatly reduce late reflections and echo by using speakers with the proper directivity. That's a measure of the loudspeaker's ability to radiate in one direction. And you'll see that sometimes expressed in a polar chart or a specification like 20 degrees vertical by 50 degrees horizontal, or it can be expressed in Q. So most of the time here in the States, we'll see it with a 20 by 50, 60 by 90, something like that. And distortion. That's an alteration from the original waveform due to overdriving of an electronic or electroacoustic source, or it can be just additional noise from background reflections. So that can also be counted as a distortion. So
We
what
find that even many times simply misusing product, right?
absolutely
A microphone simply held too close is going to be automatically overdriven and create that sort of distortion while the entire system may be working flawlessly, simply not placing a microphone in the appropriate position. And I'll tell you one thing about echo, human nature seems to really estimate how bad echo can be. Right? I've had folks say the echo in here is terrible. It's at least 3 seconds of echo. Of course, when you measure it, it's a third of a second. But human perception on it can really throw things off.
exactly. All right, so let's take a look at some audio frequencies. Just visualize audio frequency. I have not stolen. I have
Borrowed?
this borrowed from an amazing book
You
by
borrowed a
Bob.
roadie.
Yes, right. I borrowed Bob McCarthy's roadie. Bob McCarthy is one of the great audio engineers out there. And in his excellent book, Sound Systems Design and Optimization, he has a great representation of the wavelength of different frequencies. So as you see here for the average size roadie, 250 hertz is about from shoulder height to your feet. And 25 hertz is an intermodal shipping container. 40 hertz, which is about the E string on a bass, is about the length of your band gear truck. And 32, which is like a low B, is really 36 feet long. So some of these waves are quite long, and you'll see how some of these can negatively affect your system depending on room size and whether the walls are parallel. We'll go into that in a little bit. All right, so I'm going to simplify this and say that the cause of poor intelligibility is a poor signal to noise ratio. So whether it's from distortion, whether it's from background reverb, whether it's from mechanical noise, whatever it is, if your signal is not 10 dB above that background, it's not going to be intelligible. So now how are we going to deal with this? I mean, some of the challenges that architects and acousticians face these days are really huge. You know, they're the key players in defining the characteristics of a room. And then either for budgetary reasons or the owner's aesthetics, they change the architect and the acoustician's uh, plans. For example, a good example of this is in a large warehouse, and the deck uh, is straight steel, no acoustical treatment. The acoustical treatment got knocked out in the budgeting process, but when they did that, they made it twice as hard and probably twice as expensive to put in a public address or emergency communication system. So, you know, uh, try and keep those acoustical treatments in there. The other thing that can affect it is if the reinforcement system is poorly designed or the operator is not properly trained. And for those of you that have not seen Gary Larson's cartoon, Raymond's Last Day as a Sound Technician, I didn't want to put it up here, copyright, but also um, you'll see. Go look it up. It's a wonderful cartoon. So what are we going to do with this? First of all, we have to understand what we're dealing with. And then we're going to identify those causes in the room or in the system. And then testing using STIPA or even using a tool like SMART. We can identify and take care of some problems. We're going to apply that solution to the room, and we're going to test it again to verify the results. All right. So noise sources. HVAC can be a significant contributor to it, but generally that's going to be an issue in very, very quiet rooms, studios, performing arts venues, that kind of thing.
Unless, of course, the room you're in happens to back up to the mechanical room.
Exactly.
We have come across this situation as well.
Yes. And you'll see that I have a solution for outside noise, which includes that, butting your room up against a mechanical room, you know, traffic outside. For those of you who used to watch David Letterman, every once in a while the ambulance would go by and interrupt the show there at the Ed Sullivan Theater. Machinery we've touched on, and other numerous ambient noise sources. So some possible remedies for these situations are primarily with those systems, right? For HVAC, this is something that you're going to want some help with an acoustician and your mechanical contractor because it's going to require some work. You're going to need to change the duct work, maybe. You're going to need to put in some noise isolators or attenuators. You're going to need to move dampers, and you're going to need to use proper vent sizing. You know, small vents with fast moving air through them will definitely introduce noise into the system and into the room. So these are things that you probably won't be able to fix. but you should be aware of them if you're trying to get up over them.
And certainly trying to isolate those issues just to make sure that your client understands what is out of your control.
Exactly. Now, Ian and I run into this all the time, not necessarily to this extent where we didn't have to put speakers in this room, but it does represent a pretty good idea of what these rooms can
We did have a
portend.
tire factory just a couple of years ago, and that was quite the challenge.
It was, but you'll notice not only the engine noise, but everything is smooth and shiny and reflective.
Mm,
So we have to look at getting our signal 10 to 15 dB over that. And in these kinds of situations, it's very difficult, obviously, to add treatment to this plant, with the possible exception of some acoustical treatment on the deck, way up at what it looks like 45 or 50 feet up there. Um, the other way that you can change this equation for the better is by moving your loudspeakers closer to the people. If you have the ability to have the distance between your intended placement of the loudspeakers and half that distance, you can get yourself an additional 6 dB without having to do anything else to the system. So before you install them, you might want to check and see that if you can get those speakers as close to the people as possible. Now, in very high noise environments, we are asked, again, Ian at that tire factory,
yeah.
we're asked, I've got an ambient noise level of 95 dB average there, and people are wearing hearing protection. Um, in those kinds of situations, um, it's usually best to have tones rather than voice announcements. They're easier to distinguish. They can get much, much louder. And visual signals are important there as well. So, especially for any type of a PA that's going to be used to alert workers of either weather or an internal operational problem or any danger, uh, you're going to want to have a clear understanding of what's going on. Now, if you are going to put out 110 dB to get over this 95 dB background noise, be aware that increasing levels of SPL will negatively affect your STI reading and your STIPA reading. But over a certain level, your ear has a protection mechanism. So if it's much over 80 dB, your ear will start to self-protect. And over 95 dB, it's going to uh, reduce your ability to understand what's going on. Now, we've all been to rock concerts where the vocals are sitting there at 105 dB for short periods of time, and they're very intelligible, and they're certainly getting over the crowd noise. But those are very large, very expensive systems. If you have enough money, you can certainly take care of it. But in general, if you're doing this with a 30-watt paging horn, you're going to want to move that paging horn down within half a distance.
Now, in terms of these tones, right, we're talking about things like bells, buzzers,
Yep.
yelp, siren almost type of things for some of the emergency notifications. Um, so these are all useful tones to be able to have available to be triggered on public address communication systems in high decibel areas.
Right. Another way that you can do this is to boost the level of the vocals by using pre-recorded announcements, so that you can adjust those, you can compress them and tweak them a little bit to make them a little bit more uh, on top than a typical voice on a microphone would be. In those kinds of situations, you would always go in this type of situations, or you would always go with a pre-recorded message if possible. All right, let's move on. All right, so we talked about miscellaneous ambient noise. Let's take a pool or a gymnasium. There are many, many treatments out there available to help reduce that RT60 in these rooms. You can reflect it, you can absorb it, you can redirect it. If you absorb too much, and it's, I don't know, you can make a room too dead. You're not going to in this situation, but if you're putting a lot of absorptive material in there, you may want to put some additional treatment in there to add some ambience to the room a little bit.
In a room this size, though, Dan, it would be very tough to get to that point, to getting to an
Ye-
anechoic chamber level of
Yeah,
experience.
exactly. All right, and in this, when we're talking about rooms and public address, we don't want to excite low frequencies because they'll build up in a room of this size, and that will reduce your signal to noise ratio. So if you have paging horns in here, you're going to want to high pass those things way more than you probably would in general. A high pass filter of 300, 350, something like that is something you might try to reduce those low frequencies. All right, so we have electroacoustic issues. Obviously, those are things that we can deal with very quickly and identify very quickly. Damaged loudspeakers, uh, blown voice coils, those kinds of things. No loudspeakers because of an incorrect design or movement of or repositioning of workstations or equipment require additional speakers in there. If you're using a speaker that's not very efficient, you need to possibly look for a speaker that's got more efficiency. We want to see minimum 95 dB, 1 watt, 1 meter, 100, 105. Paging horns are 120. So every dB that you gain in efficiency helps you on the other end. It also keeps your power budget lower. And the last one is too much low end in the signal. If you're using 15-inch two ways, put that high pass filter in. Other issues, signal clipping, amplifier distress. If you're using a high Z amplifier and you put an 8 ohm speaker on it, that 8 ohm speaker is going to want to draw a lot of power. That's going to distort your amplifier and make things miserable for whoever is running that system. So any clipping, any red lights on the system, you need to get rid of those. So just basic troubleshooting here. Improper microphone technique or microphone. I mean, if you're using an AKG D112 bass drum mic to do your paging, it's probably not the best application for that. If you have wireless microphone issues, they probably will have been identified as wireless microphone issues, but if it's a user that's not familiar and they say, I've got all this hissing and popping, go ahead and move your antennas and get that system sorted out. And the biggest one is competing program material out there. So if you've got the equivalent of a machine room next to your room, you've got a bar next to your room, um, try and have them be a little bit sensitive to the fact that you need to be able to get over that or duck that program material. All right, so some possible solutions. Gain staging. Cut only, no boost on your EQ unless you know exactly what you're doing, how much voltage your speakers can take. If you boost 2K, 10 dB, you might expect some negative results with your loudspeakers. Check to make sure that they're not damaged, wired incorrectly, and make sure that your mic is wired correctly and undamaged. And if you're using a mic with 48-volt phantom power, how much phantom power are you giving it? 12 volts? That could be a problem.
And that wiring isn't even necessarily, positive and negatives reversed, creating reverse polarities. As you point out, rightfully so. Sometimes it's simply a matter of wiring in series and not realizing how you've changed impedance levels to something that possibly does not match the amplifier's capabilities.
Exactly. You'll find this in restaurants all the time where they take 3 microphones with stock microphones with push buttons and wire them in series back to one input on a mixer amp.
Right.
Uh,
Or
so
similarly, in Series 3 speakers, not realizing you've taken yourself down to almost 2 ohms on an amplifier that maybe is only rated to go down to 4 ohms.
correct. All right. So if we're not getting enough SPL, the best way to solve that, as I'm sure you all know, is use more speakers. Don't use more power. To get twice the amount of level out of a loudspeaker, you need 10 times as much power. So 10 dB. So use more speakers, point the speakers at the people, and move the speakers closer to the people. Again, for every halving of the distance, you gain 6 dB. So if your speakers are at 35 feet and you can mount them at 12 feet with a 20-foot distance to the person's ear, you've gained a substantial amount of SPL. And uneven coverage. So for those of you that use modeling software and are generating speaker layouts, if you're using, say, ease address or focus, that's great for SPL, but that's not going to tell you anything about intelligibility. If you show 95 dB around and it's nice, evenly spread out, you don't know what the room is doing. So for example, if you show them a picture like this, or you're relying on a picture like this to say, yeah, this is great, you have no idea what these materials are. If they decided to go, I don't know, early 50s and make all this chrome, I don't know, or a highly reflective material, that's going to, obviously that's not the case here, but you need to know what those wall materials are. And please don't, try and stay away from rooms with that are just a shoebox. Those parallel surfaces will get you.
Or as Johanna just pointed out in her message, glass surfaces. It's always glass.
Even better than chrome. I don't know any performing arts facilities that have chrome out there. I was reaching. Can you tell? It's all right. So additional noise sources. Obviously, echoes generated by hard surfaces, excessive reverb, with multiple reflections, especially low frequencies in large rooms. So you're combining that room volume with the excessive reverberation. Low frequency nodes and antinodes. So anywhere, if you have that 36-foot wave going back and forth, anywhere that it can couple, because if you add 2 waves together in phase, they'll double. So 6 dB, that's going to affect you too. So bass traps, additional sound dampening, whatever you can do, removal of low frequencies. The other occasional problem we get with uh, intelligibility is comb filtering, extreme comb filtering. That's usually not the case, but if it is, then that's going to be due to early reflections coming back out of phase, and you'll get those comb filters typically in the high frequencies. So one of the things we can do is if you use a program like Smart, to find these. You can set your system up and set it to impulse response, and you can find where those reflections are, how far they are. Then just take a semicircle, go out at that distance and see where your reflections are coming back from, and you can get rid of them. This is especially useful in house of worship applications where there's a balcony or maybe some sharp edges underneath the balcony that are coming back and reflecting back to the stage, making it very difficult for the person on stage to deliver a speech. You can also use appropriate, again, you'll be able to find out where you're going to be putting appropriate absorptive materials using that. And again, if you have a vocal mic in there, always high pass vocal mics in a room like that to increase the level of energy that we're trying to get, that 400 to 4K. So these are actually, this should be the next slide. So possible solutions, number one, you're going to want to have a loudspeaker with good pattern control. And that can be anything from a larger horn. Remember the frequency distribution on our Rode. If you want something that's controllable down to 400 hertz, you're going to want to have something that is less, that is capable of controlling it down to 400 and below. So constant directivity is important for horns, high frequency horns. They have a tendency to pattern flip above a certain frequency, usually about 4K, where the horizontal dispersion will all of a sudden become vertical dispersion. So make sure you're using constant directivity horns. You can use column arrays to trick your system into providing 3 dB down per doubling of the octave within a certain range until it becomes a point source. And the same thing with line arrays and steerable arrays. So having some form of vertical pattern control is very helpful. So here's an example of a speaker that is pattern controllable. You can go from 0 degrees to 45 degrees on this. So if you don't need much pattern control, fine. If not, you can tighten it up and hit those areas that you want very, very specifically. And Ian, you've used this in a number of different applications.
Yeah, these get used a lot in particular in gymnasium applications. Obviously, we're dealing with uh, reflective ceiling structures made out of steel. We've got concrete block walls, usually lines of uh, windows up high. So we want to make sure that we get the audio pointed downwards directly towards the bleachers. You're dealing with hard floor surfaces, hard polished floor surfaces. There's a lot of floor reflectivity there. So we really want to try to throw, I use the word paint, the bleachers as tightly as we can.
Right, and again, line array technology allows you to do this as well. Now, the point source is also a very, very good way of getting audio where you need it. The pattern has to be right, and the horn
Right.
has to be big enough. But let's not exclude point source from this. They're very important methods. And for example, using a line array in a steeply let's say banked inclined audience area, that vertical coverage becomes problematic with a line array. I used to work with a fellow in Colorado that had to do Red Rocks Stadium, which has a very, very steep audience area. And getting to the top of that was almost impossible because the top of the rig was actually below the far end of the audience area. But he was able to overcome that by his get a bigger hammer approach on those.
Secondary arrays.
Exactly. All right, so let's go back again to this. So if you have a a horn, if you look at a horn that's say 4 feet and got a 4-foot aperture on it, you're going to have pattern control well down below 400. But in order to get that with anything other than a horn that size, then you need to use a either a column array or a line array to make that happen. All right, so let's take a look at I mentioned smart earlier. It doesn't have to be smart. It could be any application that allows you to do a comparison of your microphone and the sound source and do a transfer function of those. So any 2 input source. So in this one, you can see if you're using impulse, sorry. If you're using the impulse function, here's your reflection. You would do this in time. So 17 milliseconds to about 22 milliseconds, you'd be looking at something that's about 22 feet away from you, a little bit less. And that's where you're going to find that reflective surface. And then here, this is actually a nice transfer function, but you'll see the low frequencies down here in 60. When they start to come up into this 125, 250 range, it becomes particularly destructive. So we want to take that away. All right. Well, let's see here. We've got some final tips and takeaways, and then we're going to take your questions. So my final tips and takeaways did not make it in. So I'm going to do them on the fly. All right. Number 1, take an acoustical consultant or an acoustician to lunch. Okay. Make sure that you high pass those speakers and your input sources. Treat the room first and then treat the system. If you can't treat the room, then use the available technology that we have today, and we have a lot of great technology to take care of some of these problems, to reach out very far or to restrict the pattern to a very small area. The other thing is that really long throw speaker that you put in there to take care of your warehouse, that's going to reach out and find that flat surface 150 feet away and come right back to you. So make sure that speaker's pointed at the audience. And I think that's going to be it for today. We're going to move on to questions.
Well, my first question, of course, is do you prefer a high pass filter or a low cut filter?
I prefer to cut.
Well, there was one question there. I think I misspoke earlier. I mentioned running speakers in series, and I meant to say parallel. Because that's going to then lower the impedance down to a level that might cause a problem with with an amplifier. Of course, the same thing could be the case if you're running in series and you're increasing up above, say, 16 ohms. It could also make an amplifier unhappy. So I apologize if I misspoke in saying series versus parallel.
Any other questions?
There's some Q&A over here. So what challenges arise when you are reducing the distance between the speaker and the listener? Assuming that covering the same area would require a greater number of speakers, could increasing the speaker count negatively impact speech intelligibility by introducing even more unwanted noise in a reverberant room?
Well, it can if you leave them all the same level, but when you move your speakers closer to the people and put more speakers in, you're going to reduce the level of each individual speaker. So if you're moving it 6 dB closer, you're going to have better intelligibility because it's closer, and it's also going to be a little bit louder. So you can you can certainly um, overfill a room with loudspeakers. Um, I had a design where it was a large room, and there were paging horns spaced about every 20 feet. And my usual spacing on those is 30 to 40 feet, depending on the pattern of the horn. And there was a lot of phase cancellation, it was just too much energy. And they left them up. So we ended up suggesting that they mute about half the horns in there, and it worked out very nicely.
Yeah, and it can't really be overstated the use of treatments and how important they can be, and the variety of treatments that are available, um, whether it be um, the material used in seating areas. But if you're in a large gymnasium, I think we had maybe one of our slides that had a picture of a gymnasium that I had done. I hung panels from the ceiling in a cloud formation, as well as trying to cover all four walls with 3x5 panels as much as possible. Um, you're really only going to maybe achieve a 15% reduction uh, in reflectivity, but that's awfully good. Uh, the entryway to that room was about a 15-foot by 15-foot room, again with windows and quite tall, almost chimney shaped. And the reverberation in that room would have been perfect for Gregorian chant. So here again, really having to address the room treatment as best as possible is always going to be very important. So, as you point out in that question, sure, adding more speakers or bringing them closer and increasing volume could mean you want to provide a little bit more treatment.
Right. And the other obvious problem with uh, you can't always bring the loudspeakers down there.
Right.
If
That's
there's
rigging issues
if
themselves. Yeah.
if there's no place to put them, then
Yeah.
that's a problem. So uh, what what's
Well,
always
again, then
nice,
finding speakers that you can tighten up the pattern is something that helps.
exactly. It's always a pleasure to see 30 and 40-foot spacing on columns in a room. That makes
Yeah.
life a lot easier.
All right, another question from Timothy. How can these speech intelligibility principles be applied to video conferencing, not only in an acoustical space where the sound originates, but through DSP to the far end listener?
Sure. So in video conferencing, you want as tight a room as possible. You want zero reflections in that room. What may be comfortable in a boardroom is not necessarily what you want in a video conference. If you can treat the room, everybody concerned will be a lot happier because that those noises are put through as the original signal, and you'll get some reverb. Now, the noise canceling in today's equipment is much better than when things started out that I can remember. Um, for example, using Zoom or using Teams, I have a Chihuahua, and it can bark, and that they have a Chihuahua filter on this, evidently. So the best way to do it is to treat the room and minimize the reflections on that. You definitely want um, an RT60 of less less than one, and hopefully like 0.1.
Some of the other factors that come up here, Dan, and we do get into infrared large conference room systems. So uh, microphoning is a very important factor, right? So it could be dealt with very long gooseneck microphones to be able to make sure that that microphone element is in a good proximity. Obviously, we make beamforming microphones. We've seen a lot of beamforming microphones get used in these applications, but sometimes they're quite a distance away, and it's a little bit hard for them to really overcome some of the distance issues. So having a gooseneck microphone that can be brought a little bit closer, um, or utilizing of shotgun style microphones if you get situations that I know I certainly have where attendees will push a microphone out of the way because it's close to their face. So choosing your microphone very carefully and that placement, and then as we know in our video conferencing systems, then having local speakers a little bit closer oftentimes can be very, very helpful for hearing that far end. So there are additional microphone and speaker placement issues that can be thought through for teleconferencing or just for live conferencing applications. Um, an anonymous attendee asked, "Do we have any general advice for improving STI in a conference room with ACT, carpet, and 3 glass walls?"
Yes, move. No.
Well, the carpet is certainly helpful.
The carpet is helpful and people are helpful in the room. So
Right.
is the furniture hard? Um, is the table glass or wood? Um, windows, they'll absorb low frequencies and they're really not. I mean, um, they're not as bad. They're certainly bad for IR systems, but for a conferencing system, um, how much of the how big is the room?
It did not say.
Well, maybe he can
Maybe
ask.
we'll get another response in there. Yeah.
Yeah.
Listen, glass is very difficult to overcome. Okay. Let's hear from Johanna. What do you think the best tactic is to explain the necessity of acoustic treatments to architects or project managers or upper management holding the budget? Yeah, that's always a budgeting issue, but you listen, you pay one way or you pay the other.
That's why you take that acoustic consultant to lunch. Um, uh, they they may balk at some of this, but uh, if you have access to like Ease 5, you can put together a model that will approximate the STI in the room. And again, it's a great visual tool to show what happens if you don't put that layer of acoustic treatment up there, or if you put nothing but a rubber membrane up there. It's uh, it's really important to be able to, if you're in that situation, to show them the effect. And modeling can do that. And a conference call with an acoustician can do that. If they're going to have to spring for another 20, $30,000 in PA equipment to mitigate that, then it becomes less of a hard choice for them.
Yeah, I would say that one of the other options, when if possible, would be to actually take someone on a walkthrough of an untreated gymnasium and then to a treated gymnasium, and even that 15% difference is rather noticeable. A sharp clap in the middle of that room and waiting to hear uh, that reverberation drop off, you're going to be able to tell the difference. Dan from Dan. When designing systems for multiple applications, speech mode, music mode, uh, this gentleman often puts subs on their own channel with its own volume control and otherwise just design the space for speech intelligibility, basically cutting the lows and then adding them in on their own separate volume control only when in music mode. Are there any better practices for dual purpose spaces?
Uh, no, that's an excellent practice. Presets for the room if it doesn't require a reboot of your your DSP.
Yeah,
But running the subs on an aux channel is a good way to eliminate those low frequencies, and that's going to be pretty much kick drum, bass guitar, keyboards, um, running through there. So yeah, go for it.
good deal. Let's see here. We've got, in your experience, what are the most common reasons speech intelligibility remains poor in modern audio systems, even with advanced technology available today? I would personally just say just poor implementation of the technology.
Uh, yeah, uh, without knowing any of the other variables in there, yeah, I mean, if it has been designed for the room and it doesn't work, then the design needs to change.
So let's see. I know beamforming mics are typically designed for boardroom type scenarios, but would they conceivably work for a larger room, say for a church choir?
Um, so beamforming microphones um, do a wonderful
Rather
job.
designed to chase, so I don't know.
Yeah. Uh, the, for a choir, you want a good microphone and then um, high pass it. If you got some problems, and don't do too many microphones for a choir. That's a completely different issue. But uh, it, you don't want to put a microphone every 6 feet on a choir, right? So study the microphone, experiment with the microphone, and then put in the necessary amount. Too many open microphones in a room will lower your total gain ability substantially. So keep that in mind.
And I know we've very effectively used our beamforming tabletop mic, the AM1, on flat surfaces like lecterns. So in a house of worship application there for the, that front of house speaker who may be walking back and forth somewhat, that's been useful. But uh, yeah, I would say that probably with the beamforming trying to chase sound, not quite appropriate for a
Right.
choir application.
And I mean, you wouldn't use a beamforming mic in the studio. Um, so don't use it for reproduction of musical sources.
So let's see here. We've got a question 20-foot ceiling dimensions, roughly 50-foot wide and 25. Oh, sorry. This was the size of that room. 20-foot ceiling dimensions, roughly 50-foot wide and 25-foot deep choir risers. So I guess that's the overall dimensions
with
then.
with glass. Is that the one?
I think so. I
Okay.
think that may have been.
Well, you're going to
Oh
have
no, this is deep choir risers. So this may be the room for the choir.
oh yeah. Well, you're going to be hanging. I'm now we're getting into a completely different topic,
Right.
but I'm not a big fan of microphones hanging
Dan
from the ceiling.
S at toaelectronics.com.
Yeah, ceiling microphones hanging from the ceiling. You have no flexibility unless you plan to get up there. If you're going to do that, use a little semi shotgun. Looks like a pencil,
Yeah.
and by everybody knows the manufacturer, and they're wonderful, great off axis response. But don't, yeah, not too many, and you can look up various miking techniques for choirs, but they'll always be fairly widely spaced out. And if this is not a professional choir, you're going to have some bad singers that will stick out, and so you may want to adjust your microphones that way as well, or have your
Yeah.
choir director put them in another room somewhere.
It's like the last is really more of a comment than a question. For me, everybody that runs the boards or sound for live, they dip the mids out and use way too much EQ, which sometimes does more damage than good. When the band plays live, you can hear frequencies that are ringing feedback, then reintroduce it back in through the mic vocally, and then either the DSP hears it and cuts it, or the voice analyzer seeks to cut it out.
Yeah. Just say no to feedback reducers.
Yeah,
But
sound out
yes, I
the
understood. So that's an operator problem. That's where you go to that Gary Larson cartoon.
yeah.
He's got a special button that he presses.
Well, that's all the questions that were there. I will say I've seen some very interesting techniques in the field, Dan. One gentleman who I quite fond of would walk around a room, almost moaning and wailing against various walls, uh, while clapping and stomping. He would try to basically recreate every frequency that could possibly be imagined in a room to see exactly how it would react. So It may look quite funny, but it can actually be very effective and probably very therapeutic.
Absolutely. All right. Well, that looks like it's it. Thank you very much. And we'll see you next time.
Very good. Thanks, everybody.
Okay, thank you, Ian, and thank you, Dan. And I'd also like to thank our attendees so much for joining us on today's presentation, Addressing Intelligibility in Your Audio Systems and Environment. This presentation will be available on AVIXA's website, and the location is avixa.org/webinars within about 5 business days, and your one renewal unit will be applied to your transcripts within those 5 days. If you have any trouble, please contact AVIXA's webinar team directly, and that is at webinars@avixa.org. An important side note for CTS holders, if you registered for the webinar with an email address other than what we have on file for you, you will not get credit for attending. We can get that fixed, however. Please email membership@avixa.org and let your account manager know that you used the wrong email address, and then we'll get it corrected for you on the back end. I just want to give a huge thank you to our sponsor, TOA, and another thank you to Daniel and Ian for helping us to evaluate site conditions that affect your system's intelligibility. Be sure to continue the conversation and connections you made today by joining the AVIXA Exchange. It's an AV provider directory and a year-round community where you can grow your network and stay updated on current industry trends. We hope you've enjoyed our webinar today. Thank you all, and make it a great day.